Sorry. Anyway, welcome. Thank you for showing up. My name is James McCaffrey. And the first thing I'm going to say is that this presentation, or this time slot, is 90 minutes. I don't know about you, but I can't sit through anything for 90 minutes. That's just way too long. And so this presentation, I don't know how long it's going to be, but I'm expecting roughly 45 minutes or so, because that's usually when I run out of interest in myself. So if I'm starting to bore myself after 45 minutes, I figure you guys are well beyond that. So I make no apologies for that. It's not like there's a certain amount of content that I'm going to try and stuff into your heads and I need every second. In fact, that leads to kind of the next question is like, why are you here? And I'm almost kind of serious about that. I'm curious about your motivations. Because clearly, you didn't look at the title of this talk and say to yourself, whoa, awesome. This is exactly what I wanted to learn at MMS 2012 and I can bring back and use tomorrow, I'm guessing. My hunch is that you, one of a couple things, saw the title and go, okay, this is going to require no brain activity on my part whatsoever. I can sit for the first few minutes of this. And it might really suck, but that's okay, because I'll sit near the exit and just be ready to go. Yeah, I see you guys back there. Yeah, there they are. Okay, you can all raise your hands as the guys sitting near the escape hatch. Actually, it shows that they've got good sense. And that's one of the reasons why talks, I'm serious now, where there's a little bit of a delay in the beginning, because I encourage you, you know, your time here is very valuable. It took a lot of time and effort for you to get out here, and you want to gain as much value as you can. So really do, you know, poke your head into different doors. Talk to your colleagues about what talks were good, and or meaning, you know, are good for you. And if you're stuck in a talk and it's not meeting your needs, just bail out. You know, speakers are not going to be insulted by that, other than me, of course. I mean, I'm going to take that very personally. No, if you find that it's not it should be either educational, you know, meaning provide you with some new information, or entertaining in some way. By that I mean, okay, you know, I sat through, it was kind of interesting. Or hopefully a combination of both, and that's my goal here, is to provide you with some actual useful information, which may sound surprising based on the title. Some useful information, I'll explain what that means as I go along, but also do it in an informal and hopefully entertaining way, okay? And part of that important thing is, you know, when we're done after 40 minutes or so, we're done, okay? Okay? So what am I? I'm James McCaffrey. I've worked at Microsoft for 15 years. I'm currently working in research. Before that, I worked in the product groups where I actually produced useful stuff as opposed to Microsoft Research. No, that's our joke. You know, research guys sit around and think. I don't even do that, you know, according to my peers. But more to the point, I really live primarily in the developer space as opposed to the IT space. Now, when I point that at you, one of my themes that's coming up in the next slide is that I believe that all of these fields are kind of merging, in particular the developer space and the IT space, and it is going to affect you sooner or later in some ways. And the more you know about this and the more you're prepared, the better you'll be able to take advantage of it for your personal career growth and for your company's growth. So that's my motivational speech. Do you feel all motivated now? Like, woohoo, I'm glad I came. Maybe. Okay, here's my agenda. Please notice the flashing GIF there. I harnessed my vast PowerPoint skills. That's the only animation you're going to see, and clip art. I don't even know why that check mark is there. I forgot why I put it there. Why did I put that there? Oh, I know what it was. I didn't want it. The check mark was part of the Canon thing. Okay, so I had to take it, and it was flashing. Now, raise your hand. I'm not even sure. I just got into town. I'm presuming since this is the first day that there haven't been that many talks yet. Were there talks in the morning? Yes or no? Yes or no? There were? Okay. So many of you, if you've been to MMS before, and MMS does tend to get repeat customers, which is a good sign. But if you're a repeat customer or if you've seen some of the presentations, there's only one thing, pound for emphasis. on this agenda slide that is important to you as a listener? What's the important thing up here? And it's a little bit hidden. Sometimes I make it a little bit more. Anyone want to speculate what's important on this agenda slide? Think, you've heard enough of me to know he's the cynical, cranky old guy. Okay, so it's not going to be something obvious. What now? No. What now? I can't even see who's talking. I'm blinded. Oh, no, first slide. Actually, yeah, that's kind of a no number one, sort of a misnumbering bug. Okay, the point, I'm so ashamed of you all. It's that there's only 13 slides. Okay? Have you sat through some of these presentations with 40 or 50 slides? I mean, that's crazy, right? So, and in fact, there aren't even really 12 or 13 because the agenda, this one counts as one. So there's only a handful of slides. There's about a dozen slides. I intend to spend roughly 2 to 3 minutes on each. Then plus my showmanship here, that'll bring us to roughly 45 minutes. When I grew up in Southern California where I went to school, and like many people there, I worked at Disneyland in the evenings. So what you say? Well, everything I learned about human psychology I learned from Disneyland. Raise your hand if you've been to Disneyland or Disney World in the summer. Yeah, I guarantee you all did that one time only, okay? Because Pirates of the Caribbean, for example, is a 13-minute ride, about. And on a busy summer day with 60,000 attendees, you can wait up to 3 hours for that thing. Well, what I learned by working at Disneyland, which has nothing at all to do with this talk, we're still waiting for the stragglers to come in and out. Right now, the people who are coming in probably were sitting in a presentation that was so astronomically bad that they could only take the first 90 seconds or so and are now sort of like refugees. That's what I'm believing. And so the real talk will start in a minute. But what I learned working at Disneyland is, and you'll notice this at the airport. Okay, so I'll rephrase it. Suppose you're at the airport, and this may not have happened to you, but you're told, or it just says delay for your flight. It just says there's going to be a delay. And that's all. What? Are you satisfied with that? No, it creates enormous tension, right? Because you don't know, we're replacing a light bulb and it's going to be 30 seconds, or the wheel fell off and you're going to be here for 3 days. Well, it's the same thing at Disneyland. People did not mind waiting in line 3 hours for a 5 or 10 minute ride as long as they knew that's what the wait was. Okay, Disneyland figured this out, you know. Okay, your wait time is this. Okay, people go, okay, I know I'm going to be tortured, but the uncertainty of the torture has been removed. So, my point is the uncertainty of your torture has been removed. You're only going to be tortured for 12 slides in the worst case scenario. Now, this is a way longer than most of the presentations I give, but basically there's sort of like 3 chunks. In the first chunk I'm going to sort of explain what this is about. Then the second chunk is those ML things for machine learning. Okay, fancy term, doesn't mean much. Then the second or the next clump is those IN, information networks, and I'll explain what that means, and then we wrap things up. Now, when I go back to this, my gifts are intended to do this. One of the things I found, I live in this world. I've lived in this world for decades. And it turns out that the information, the vocabulary, okay, raise your hand if you've heard, okay, well, there's a good start. Okay. Raise your hand if you've heard the term artificial intelligence. Well, of course, you're going to raise your hand. I was at a talk with a different company, and the speaker was hilariously bad, okay, because he asked some question like that. Raise your hand, and it was the wrong question, and nobody raised their hand. And he was oblivious to that and said, good, good, and continued on as if everybody in the room had raised their hand. In other words, he didn't really care. Anyway, now this one I sort of care about. Raise your hand if you've heard the term neural networks. Okay. Now, raise your hand if you really deeply, understand what a neural network is and what it does. Okay, a few of you. Okay? My point is this, that there's a whole bunch of vocabulary around. The topic is artificial intelligence and how you're not using it now, but you probably will be. Unfortunately, even in the field of artificial intelligence and all this, the vocabulary, terminology, I mean, experts will fight over the definition of this and that and the next thing. And try to, a taxonomy is a fancy word to say a list or categorizing things. There's no way to categorize this. So my package with the red cross thing to the stop sign through it means that it is not possible to neatly package up this information. Okay? And it would be futile to do so. But what I'm going to do is, I was going to use a shotgun as my icon, but then I figured I'd get stopped at the airport or, a shotgun, it just was a little bit too creepy, so I got a cartoon can. What I'm going to do is throw at you the 12 topics that if you know those topics, if you understand 12 topics, and by understanding I mean with a few sentences each, you will have a solid grasp of artificial intelligence and enough to communicate and understand it. So I'm giving you the shotgun approach instead of the tight, nicely bundled package approach. Okay? And believe me, I would love to have given you, here's how it works, and here's, I'll email you the presentation, but it just doesn't work that way, even for people that have worked in the field for decades. Okay, so here's, out of everything, I think that if you come away, in fact, this presentation has been designed for you to, it will be made available to you somehow. I forget what the mechanism is, but I know that you can get these presentations somehow. I don't expect, when you leave here, hopefully at the end, not in the middle, I don't expect you to remember all of the details, but I do want you to remember the general themes so that if it's necessary, you can pull this up and review it, okay? And look at it. So that's really what the thing is. But this slide is the one thing that you should take away. In other words, when you leave, this is it. So this is my opinion. Okay, well the whole thing is my opinion as opposed to anything else. So trend, explosion of devices, right? I think that should be obvious. What does that mean from an IT perspective? What devices? What do I mean? What kind of devices are you and your enterprise supporting now that you weren't supporting 10 years ago? Mobile devices, of course, are the big things, okay? But there's all kinds of other devices too, and that's only going to increase. Pretty soon, automobiles. A lot of it's related to GPS, geolocation data, all kinds of stuff. So, explosion of devices. In the old days, if any of you are old timers, basically your IT world consisted of some crappy old desktop machines with a, what was the old, I was hugely popular, the network, pre-Windows. Novell. How could I forget that? I mean, how soon we forget, Anyway, second trend, increased collection of data. Now, this may or may not be true of your personal experience, but among the people that I talk to, the clients, because on the thing, I'm the senior contributing editor for MSDN Magazine, which is Microsoft's developer journal, has about 300,000 subscribers, and Visual Studio Magazine. Okay, those are developer things, but they tell me that most of the clients I talk to that they're grabbing more and more data. This is something that again, this is a query. I don't know. Raise your hand. Okay, your choices are going to be yes. In my world, I am seeing an increase of data, or we'll go increase in data, decrease in data collection, or relatively level. So raise your hand if, okay, I don't expect anyone to raise that. Decrease in the collection of data. Didn't expect so. Okay, relatively stable collection of data. Now, okay, raise your hand, increased collection of data. Wow, see, and I was actually looking, and I did not see a single person raise their hand for stable. I expected there would be a few, and that could mean basically, you never want to be the first one to raise your hand, although IT people are different. So, well, anyway, good to know. Then trend, move to the cloud, and of course, I think at this event and most of the other events, it's all cloud this, cloud that, cloud the next thing. Well, I'm a believer. being an old cranky guy, I'm skeptical about the latest, greatest thing, but this is something that I really believe is here, and I think it's a paradigm shift and important and all that stuff. Raise your hand if your enterprise is at least probing the use of cloud data. Most, not all. Okay. We can speculate about that. The theory is that cloud is going to be adopted first by very small companies and very large companies, but not the middle-sized companies. Anybody want to, I mean, this is a theory, no data yet. Can anyone like theorize why that? Why small companies, why large companies move to the cloud? Cost, okay, cost primarily for the large companies. Large companies, if you can save 1%, you know, you're talking about major bucks. Small companies, on the other hand, very small, don't have anything to lose. Why not give it a try? It's the middle companies, which is the bulk of them, that are normally or expected, hypothesized to be the trailing adopters. And we see this happen in lots of other technologies. Anyway, that's a trend. Trend, rise of project-based work environments. We've noticed the IT world seems to be becoming more and more projectized. In the old days, and here I'm going to say in the old days, it's probably your current thing, where the IT world consisted of putting out fires. Email servers down, you know, I mean, just like reacting to emergencies and struggling just to keep your infrastructure alive, much less, you know, building it or making it more efficient. But once things get more stable, and I think you'd have to agree, maybe not, but I think you'd have to agree that the IT world is dramatically improved. I maintain my own private networks by myself. I mean me. I used to have interns that do it now myself. And in the old days, I had to have 3 college students on it pretty much all the time just to keep it up and running. Windows 3.5, you know, stuff like that. But now, I've got Server 2008 R2, and it just runs. I mean, these things, commodity Dell machines, they've been running for years, a couple of years without any problem. Anyway, when that happens, that allows or permits the IT environment to move to more project-based work, where it's a discrete chunk and we're going to do this project because we don't have to worry about putting out the fires so much, we believe it's going to run. Now, if those are true, my conclusion, based on no data whatsoever other than me sitting around thinking about it at the bar, is that I kid you not, I refuse to read the slide. What do you do if you're sitting in the back room near the door and the PowerPoint comes up and the presenter starts reading the slide, bullet by bullet? What do you better do? You better get out fast because it's going to be a miserable experience. Okay, raise your hand if you can read. Okay, hands up, yeah, read it, okay? I'll try to not read it and amplify it or summarize it. Now, I guess, well, let me ask you this. There I'm reading it. Shift from a highly annoying reactive tactical support role. What do I mean by highly annoying? Annoying to whom? You're going to have to speak up loudly because it's hard to hear. Everybody. Well, okay, everybody. Namely, we can rephrase it like this, that it's annoying to you because you're putting out fires, and it's annoying to the company as a whole because you're just being reactive. Anyway, the switch to a highly valued, well, highly valued, what does that mean? Well, proactive, that means not waiting for it, doing it in advance. Strategic, so tactical versus strategic. Strategic means more long-range business. See, it boils down to this, and I hope I'm not going to be insulting anybody. I really do. But I think you'll agree, and again, no basis for data here, that the IT in a large organization, and I don't know, but I'm speculate, I've seen movies like Office Space and all these other things. The IT department isn't the most highly valued department. In most companies, what department is the most valued, would you say? Sales. Sales. Because they're closest to the revenue generation. If purely speculate. Imagine that you had your own company and you had an IT information. If it was somehow possible to press a magic button to eliminate all costs associated with that IT department, would you do it? You probably would, because IT in many organizations, not always, is primarily a support thing. In other words, it's overhead, it's the cost of doing business. My claim is that once things become stabilized, IT can move closer to sales. By that I mean closer to revenue generation, and I think that's going to be good for everybody. It's going to make your company better, it's going to make your job more interesting, it's going to make your careers have a better trajectory, maybe. Basically, that was the talk, and now I go through, and it's the shotgun approach to 12 topics. So, trying to untangle the vocabulary. Machine learning. You can look all this stuff up on Wikipedia, of course, but the first thing you'll find is that there's no clear consensus on any of these definitions. I think, when I hear machine learning, I think existing data, make predictions. Making predictions. Is it useful to make predictions? Would it be useful to be able to predict the winner of the Super Bowl? Would it be useful to be able to predict the fall of a roulette ball? Of course it would. So, making predictions. And that's what I think of machine learning. Of course, that's not it, but for your purposes, if you think machine learning, making predictions, you'll be very close and right on track. Information networks. One of the things that's been popping up recently is, and it's more IT related, information, social networks. You guys have the potential to be the key players. Your organization will have the ability to harvest email connections, IP connections, and stuff like that, and these all just form networks. So information networks just mean any kind of things that are connected. They can be people, they can be machines, or they can be chunks of information. Yeah, have you noticed, I'm sure you've gone to Amazon. It's hard to imagine anybody who hasn't bought anything from Amazon.com. Well, out of curiosity, is there anybody who has not? Really, interesting. There are a few, which stands to reason. I won't go there. Okay. But if you've ever purchased something from Amazon.com, you go back and they will give you suggestions, right? And they're usually surprisingly accurate. You might be interested in this. And I find myself, usually I see any kind of ad, click away immediately. But with Amazon, I go, dang, they're right. That is kind of interesting. I might be interested in that movie or that book or something. And that's a kind of information network too, the connection of purchases. Then the third thing is artificial intelligence. Artificial intelligence you should think of as the techniques that are used to solve information network problems and machine learning problems. So in short, machine learning, making predictions based on data that will be in your area. Information networks, very similar, establishing relationships between data that will be in your area. Artificial intelligence, techniques to make it happen. I've got a lot of other stuff there. Okay, now basically I'm just going through and giving you a one-slide summary of what I picked. I did spend a lot of time on this. And I thought, okay, if I had a room full of people, IT experts, IT engineers, IT specialists, whatever, and I wanted them to leave going back to their company, knowing or having an overview of artificial intelligence stuff, what 12 topics, because I didn't want any more, what 12 topics would I give them? And so there's one slide per topic. It's not everything, but it's sort of like, oh, imagine this. Imagine you were doing this. Imagine that, do you have, oh, okay, I know this, right? You guys work in IT, right? So, when you're at home and someone in the neighborhood's got a problem with their computer, who do they call? You, because you're the expert, right? You can fix anything. Why does it, my daughter's laptop, parentheses, that's riddled with Facebook viruses, doesn't work. Can you fix it? In the same way, if you wanted someone to completely outside your world to know the 12 most important things about your world, So this is the analogy. So this is called machine learning, a way to categorize logistic regression. Logistic regression sounds real fancy, right? Logistic, ooh, regression. Oh yeah, I remember that word, so it's got to have something to do with math. Well, it's real simple. You have some data, and in one of the columns of the data, there's zeros and ones, and that's what you're trying to predict. So I made up this artificial example where you've got some IP address, some time, some other time, and then you've got historical data that determined that that was a virus, incoming or it wasn't. So you would have some technique. Well, I'm going to go into a little bit more. Logistic regression just assumes that there is a magic equation. And that magic equation is 1 over 1 plus e to the minus e. Don't leave. You're going, oh great, e to the this, e to the that. It doesn't matter. The point is, it's a magic equation, okay? X plus 2y, okay? Now, you don't need to know where that comes from, because later on I'll show you. You're not going to be solving the equations. You're going to be explaining the data to the propeller heads that do need to solve them. You're the ones that understand what those columns mean. So it's some magic equation, and then notice that z, and then z is B0, some number, 3, 7.2, 3.14. Some number plus B1, some other number times the address. It means multiply. Where obviously you can't multiply some number times an IP address, so you'd have some way of turning an IP address into a single number, okay? Those are the nuts and bolts, it doesn't matter. Anyway, so you've got that. So there's the magic equation, and the magic equation is, or the challenge is, what are those numbers, the B0, 1, 2, and 3, that solve the equation, not really solve. What are those 3 numbers that make my predictions work? Everybody get it? I mean, it's simple. What are they? Well, and then there are techniques, and then you find the best. By the way, what I mean best? Well, you're not going to get 100% accuracy. You want the numbers that predict the most times correctly. Then, that's called your training, then you get some new message coming in. You run your magic equation and say, there's a good chance this is a virus or very low chance it's a virus. You're making a prediction, right? Think about it for a second. I got to say I was pretty lame about making my dummy example where you're trying to predict something that's 0, 1, meaning it is or it isn't. Okay, that's the most fundamental kind of prediction. Can you think of anything else in your, I'm serious, I couldn't come up with a good one. Well, think about it. If you could think of someone, tell me later, because the next time I give this presentation, I'd like to take a better slide. Slide 5. We are almost halfway done. And so we go, thank goodness, no. Okay, here's the next thing, neural networks. This is the one that you've heard about, and you've heard about, and you've heard about. It popped up in the 1980s, and like so many things, it was going to solve it was going to solve world hunger, it was going to scratch your back, it was going to do everything for you. It was overhyped, and then because of that, because it couldn't live up to those expectations, the pendulum swung the other way, and it became very unfashionable. Well, it turns out that neural networks are starting to make a comeback. Now, remember that last slide where you're trying to predict 0 or 1? Think neural networks are logistic regression on steroids in terms of what they do. Instead of predicting a 0 or a 1, neural networks can predict any value, including zeros and ones. Okay? And instead of a single magic equation, and I'm sure you've all seen diagrams like those on the bottom with circles and arrows going every which way. All that represents is an equation. Instead of a single magic equation like for logistic regression, neural networks have the ability, by modifying the number of circles and how they're connected, the magic equation can be any equation. Amazing, right? So, I mean, you don't just take it to the next step, you expand it. So you can predict any value that follows any equation, right? That's what a neural network is. Okay, one of the key things, though, is it's numeric. You're predicting numbers. So what's the problem with my data in the upper left-hand corner there? the green, blue, red business, you just have to have some way to, just like the IP to a number, you have to have some way to convert that into a number, okay? And that's, you know, I mean, like if this was a class on neural networks, then we'd spend an hour figuring out how do we convert red into some number. Okay, we got it? So number 2, logistic regression, magic equation. Neural networks predict anything, and it's any equation where the equation is determined by the architecture. Pretty simple. Now the interesting thing, okay, this one of the things I've noticed about this whole field is that there's no clear distinction, even among the experts, between the kind of problem you're solving and the technique or the tools you use to solve it. This doesn't happen anywhere else. Particle swarm optimization is a technique or a tool to solve either logistic regression or neural networks. Remember, in both cases, you have to find, in my previous slide, in my previous slide here, it's hard to see, but the challenge is to find the weights. Do you see there's a crap load of numbers in there on the right-hand side? Those are like the B0, B1. Instead of having to find B0, B1, B2, you got to find dozens and dozens of magic numbers, which makes sense, right? It's a more complicated problem. So, particle swarm optimization is a way to find these magic numbers. Now, I sort of intended, I mean, I've got this thing up here and I can go into detail on it, but I think if I went into the details of particle swarm optimization, you would lose the main point, okay? The main point is particle swarm optimization is a technique to find the magic numbers for something that can make predictions. I'll leave it at that and you can read on it, but down in the corner, I added this in at the last second. The real question is, particle swarm optimization, what? It's this wacky algorithm that's based on particles moving around, like flocks of birds. Have you seen those nature shows where birds, they sort of move together, but every now and then one spins out of control and they do all this kind of stuff? Well, it models that physics, and you go, what? How? Just trust me, you know, the mathematicians figure it out, that's how they guide their algorithms to solve the problem. But the question is like, why would you want to solve a math problem with particles flying around in hyperspace? And down there in the corner is that one of the reasons why artificial intelligence is experiencing this renaissance and could make it into your worlds within a few years is that all these classical, like logistic regression has been around since the 1920s. However, they're always solved using classical calculus-based mathematics that starts like this. Step 1, put your data into a matrix. Rows and like Excel. Step 1, put your data into a matrix. Step 2, use calculus to differentiate the function. Okay, well, you can stop right there. Those techniques were used because that was the only techniques that existed in the 1920s. Now, well, first of all, what would be the problem if we said, take your data, I'm talking about your data that you work with to make a prediction. Take all your data and put it into a matrix in machine memory. What's the problem there? Yeah, you can fit roughly into a ordinary desktop machine, maybe 10,000 by 10,000. Maybe, if you got a pretty beefy machine, more like 5,000. Would it be possible to have tens of thousands, a log file with 10,000 entries? 100,000 entries? Yeah, I mean, there's no way. Artificial intelligence, including this technique, can deal with arbitrarily large amounts of data, okay? So that's the difference. You know, there's this disconnect between people using 1920s techniques and these new techniques that are based on things like this. Okay, now we're more than halfway through. And bacterial foraging optimization. Okay. This is another technique. It's a cousin to the particle swarm optimization. It is another technique for finding the magic numbers. But instead of based on particles swarming, you can guess it's based on what? Based on bacteria, like E. coli doing their thing. Okay? Now again, you know, most of the time when I give the similar presentations, there's a big disconnect in your brain going, okay, I understand finding magic numbers. Okay, I understand bacteria. But I don't see what possible connection they would have. And we'll just have to say that you're just going to have to trust that there is a connection. Okay? When people who are mathematicians like me write algorithms, we use these things. Briefly, a bacteria. Think about a bacteria swimming around. Are there bacteria right here on this table? Yeah, there are. Tons of them. They're the most successful organism. If you took the total mass of all bacteria in the world, I forget what it exceeds, but it exceeds something like the weight of all living animals or something like that, all mammals, I don't know, something like that. But bacteria have a position, okay? The position represents a solution. So you don't just have, like calculus-based techniques, you aim, the matrix is going to solve it. Here you've got a whole bunch of stupid solutions, stupid bacteria, where their position is a potential solution. They move around, and they sort of reproduce. And anyway, that's basically, you can translate that behavior into mathematical algorithms. Now, this is one that you've probably heard about, where we've only got a couple slides left here. Machine learning, evolutionary. Okay, so where are we now? Machine learning, making predictions. Making predictions boils down to solving magic equations, either simple like logistic regression or incredibly complex like neural networks. How you find those magic numbers are either, what do we say, so bacteria or particle swarm or evolutionary algorithms, sometimes called genetic algorithms. Now, I'll bet you've heard of those, right? Genetic algorithms. But you probably go, I don't know what they do. Well, this is a third way to solve the magic numbers, and it's based on, instead of particles or bacteria, it's based on chromosomes. Okay? And again, for the third time, you go, I get chromosomes, sort of, although I didn't really, my biology teacher in high school was so bad I didn't really grasp it. But again, you can map these things. These have been around a long time. Okay, now, this is sort of the final chunk here, other than that first part of the talk was all about machine learning. If I had to ask you now, you walk out, before you start drinking tonight, machine learning and what word? Machine learning starts with P. Please, somebody save me. Predictions, thank you, yes. The second part is, okay, we talked about that. Now, information networks is about relationships. Now, the distinction is difficult because we're only, ultimately, what matters? Money. I mean, you can always, but of course there's many, asterisks to that. The only reason you'd want to go to a bunch of trouble to figure out relationships between data is so that you can somehow have something to do with money, which presumably you would use for something good, for quality of life or making the world a better place or something like that. So, graph partitioning. Social networks and all these things are all about large graphs, really large graphs. And you can imagine the circles as either people, or probably in your world, the circles probably represent what? Machines, servers or clients. The graph partitioning problem is these graphs can be astronomically large, far beyond human comprehension. For instance, the challenge is to break them up into smaller chunks that are manageable. And it turns out, it sounds pretty easy, but it's a really hard problem. So the example there I've got 12 nodes, which can be users or machines. And the challenge is to divide them into two groups of 6 so that the connections in each group are maximized and the connections between the two groups are minimized. So the solution to that one is, do you see that white line across the middle? That's the solution. Now, this is something that human beings are very good at, but machines are very bad at. But it's a fundamental problem, and down there, anytime as giving a talk like this, I have to throw in the fancy Greek letters. So there's the obligatory fancy Greek letters so that I can impress you with my knowledge of the Greek alphabet. But that's an actual equation, and to give you an idea of how hard this is, if you had only 40 nodes, 40, that's not very many, and you had to divide it into 8 chunks, of 5 each. That's how many different ways there are to divide that up. It's one of those things, you know, good bar bet and stuff like that. Okay? Well, what isn't a good bar bet? Okay, so this is a fundamental problem. Another fundamental problem in information networks is the maximum click. It's pronounced differently, sometimes click, sometimes clique. Okay, but click is the more generally used term. A click, you know that term from like, you know it in general usage. A click is a bunch of people that hang out together. So in information technology, a click are nodes that are completely connected to each other. So over there, what is the largest click? I made it pretty easy to see. Everyone see the group of nodes where every node is connected to each other. So they're a click. They're all together. Do you see the 0, 1, 3, 4 click? They're all connected to each other. Well, why would you want to find that? Amazon.com is particularly interested in a problem like this. Why would they want to know if the nodes represented people? Why would Amazon want to know who is connected by some way to whom? Marketing. I mean, because this is spread of influence. If you can somehow target the people in the maximum click, you get the most bang for your buck, thinking that they will spread that information. Biologists are concerned about this for the spread of diseases and things like that, but that's not as much fun. Okay? So, maximum click problem and the shortest path problem. The shortest path problem is probably the most common problem, but, I mean, it's useful. But I think it's the least directly useful in many cases, where the shortest path problem is to find the shortest distance from spot A to spot B, or, you know, I mean, from one point to the other. Okay? This is interesting because it could be useful in an IT world. Well, I mean, the shortest path algorithms, among their first applications was in network topology, right? You want to minimize the number of hops from machine to machine because of the slow speeds. But I'll just say that the thing here is that it's the third major information networks problem, and it also is insanely difficult where if you have 20, they're usually considered cities, but 20 machines, and there are that many ways to go from one point to the other. Roughly. Okay, I'm going to skip over this one pretty fast. So remember how in the first chunk we said what the problems were. Logistic regression and neural networks. They're ways, and then there were techniques to solve those problems. Now what we just saw that there are certain problems in information networks. The shortest path, the click, and the partitioning. There are ways to solve this problem, and one of them is called simulated bee colony algorithms. Okay, about this point you're going, okay, bacteria, bees. Is there any animal that they don't have a model after? The answer is yes, many animals do not count. Although if you want to get famous, pick some stupid animal and create an algorithm based on what's the dumbest animal you can imagine. Well, I mean, your users in your network don't count. Anyway, no, we'll take that offline. But anyway, the bee colony algorithm is an algorithm based on the behavior of bees. But instead of finding the magic numbers, like we saw earlier, this one finds the magic combination of things. So it doesn't deal with numbers anytime you have an ordering of things. So think about that last problem, the cities problem. You can go from A to Z to whatever. Well, the bees solve this kind of a problem. Well, according to my calculations, that was it pretty much except for the wrap up. Summary. Oh, wow, that was pretty fast. That's okay. I mean, I said my message and I'll stick around and answer questions. I'm not going to. Do you ever have the university professor or high school teacher that said their deal in the first 10 minutes and then realized they had to stall for the next 30? Well, we're not going to stall. We're going to present our information to you in the most efficient way possible, I hope. So, summary. I claim, and you can find, it's a safe claim, but you could probably find dissenters at this conference, that IT engineers will start using AI techniques on huge data sets. But the point I want to make is you're not going to be the ones solving B equations in neural networks. You're going to be the ones that need to supply, because all that's easy. I tell you, that's easy. The hard part is understanding what that data means. What do these weird things happen? What happens if, something fails or something like that? And that's where you become a consultant to the propeller heads. Propeller just means someone, math geek like me, okay? Here's another term that sort of I glossed over. Classification means putting things into classes. For instance, we could class here by gender, male, female. There's a horrible joke, but since I'm being recorded, I cannot go there. I guarantee I would no, offline later at the bar. We could classify based on age, different buckets of age, and so on and so forth. But the whole point of classifying data is so that you can make predictions on future data. Graph analysis is related to information networks, and the three main problems, by no means the other, I mean, you could study the rest of your life on these, is clicks, connected groups, paths from one node to the other, and partitions, chopping them up into manageable chunks. Up there on classification, logistic regression, where you imagine one magic equation with that E thing in it, or neural networks, which is the whatever equation you want it to be. Now, these old problems that have been around forever and ever can use the new AI tools. And why do we need new tools? Why don't we use the old 1920s tools? It's because of the large size of our data. We're not dealing with, I kid you not, when I was a student in college in the late 60s, 100 data points was considered huge, because you had to do it by hand. It would take hours, days. And then finally, because of all this, and combined with the stabilization, and I really do believe, I could work wherever I want, but I believe in Microsoft products. I've seen them work firsthand in my world. I don't have to worry about my network as much, other than SharePoint, but that's another story. Sorry, you can't get through a talk without a SharePoint bash. It's just part of the deal. But because of the stabilization, large data, and all those trends I had, that your role could conceivably become more closely aligned to the sales department. In other words, another term is business intelligence, where the data which is gold is going to be your responsibility, and you're going to be the keepers and understanders of that knowledge. You can collaborate with the brainiacs and the math nerds to provide useful information. Typically that means predictions, and typically that means money. I mean, ultimately every company is in this Darwinian struggle for survival, and not a lot, but part of that's money. Now, you're supposed to applaud at this point. No. That was my job. At the we're wrapping up. I see. 3 minutes left. I'm looking at this clock. I kid you not. This is how stupid I am. I thought it said I had 34 minutes left. In other words, I thought I'd been talking for 12 minutes. Okay. Well, I'm right on time then with my 45-minute thing. Good. Now I don't feel so bad. But anyway, first of all, thank you for coming. I hope, like I said, my goal was for you to leave having a little bit more information than when you came in, and that it wasn't a horrible experience for you. There is my email address. Now, if I didn't want you to write to me, I wouldn't have put it up there. If I didn't want you to write to me, I would have put the email of my annoying coworker across the hall, Paul. He's Canadian. No, I love Paul. But go ahead and write to me if you have any questions. This is my world. I love to talk about this stuff. If you see me drinking at the bar, which is very likely because this is my last talk, come up and chat with me. I love to chat about this. And this is embarrassing. I'm not joking again, just like thing. If anybody has a camera, I don't have a camera. My phone doesn't take pictures. My phone doesn't take pictures. It doesn't do texts. All it does is do phone. It's from 1990 something. I'm not joking. But anyway, if anyone has a camera, please take a picture of it to me. I'm serious. I'd love, and send it there. I'd love to send it to my mother, who is, lives in Southern California, and she likes to see pictures of me because it makes her happy. And that way you can, oh yeah, also if you have Photoshop abilities, please make me look a lot more like Brad Pitt or somebody else. But thank you for coming. And now, at the awkward end here, I encourage you to leave if you don't want to stick around. Sometimes people feel the need to be polite and listen through questions that they don't have any interest in. If you've gotten your fill of me, then go away. But if not, stick around and I'll answer a few questions. And thank you again for real this time.